the Azure podcast. This is episode number 460, being recorded on the 19th of May, 2023, with special guests Akshay, Vijay, Neha, and Garv. And with me on Teams, of course, I have Cale and Evan, and we're going to get to this very special group of students who are all from Penn State. Talk about the work that they're doing on Azure. But before we get there, let's just cover some news. I believe Evan and Cale, you had a couple of items to talk about.
Sure, go ahead, Cal.
Yeah, the only one I have to talk about is Build. So just want to remind our listeners that next week is Build. It's virtual as well as I think there is in person, but you can. We'll put a link there, and you can go see all the sessions and whatnot, all kinds of good stuff there. So I think we've talked about it in past podcasts, but I just want to call it out because it's the next week, so just a few days away.
The news that I want to chat about was the max surge capability with virtual machine scale sets, right? So virtual machine scale sets are nice because you have this pool of VMs, and you can do guest OS upgrades, application upgrades, and it sort of rolls through them and does them in following your update domain rules. But the problem has always been historically, let's say I need 5 VMs to withstand my load. It used to be that we would take one out, upgrade it, put it back in, take another one out, upgrade it, which means you're actually running at 80% of your compute capacity versus the 100% you might actually need. So what the max surge does is it actually creates and upgrades a VM and then adds it to your pool before it removes one. So net is you still keep your baseline of compute capability. So this has been something I knew that the team was working on. I'm dying to see this go public. What'll be nice is as this starts surfacing on the PaaS services that leverage VMSS as well. I know some of the services have adopted it already, but great feature for making sure you can always withstand whatever load that your service is under, no matter what happens to underneath you.
Awesome. Yeah, and just on that build thing, I was going to mention it to our guests over here. That's something that they can share with their fellow colleagues in at the university. I mean, it's a great way. It's a developer conference. Microsoft Developer Conference is coming up next week. It's free. You can attend it virtually. It's got some great sessions. Of course, there's a lot of Azure sessions as well as just software engineering, software development stuff, which I'm sure every folks in your team will be interested in. But yeah, let's get to our guests here. Thanks so much for coming on. Please go ahead and introduce yourselves. We'll start with Neha and then go around the table here. Neha, go ahead and introduce yourself.
Yeah, so hi everyone. I'm Neha. I'm doing Masters in Computer Science at Penn State University. Also, I've got around 5.5 years of work experience. So I mainly work in virtualization, storage, cloud. Also, with this team, I've collaborated with them and we've done some work. I worked on machine learning. So yeah, this has been my contribution to the team. Yeah, so that's it about me.
Awesome. Thanks. Let's say, Akshay, why don't you go next? Akshay,
you're on mute, Akshay.
You're on mute. Yeah.
It's not a good recording unless someone's accidentally on mute. Right now, we've broken the ice.
All right. So yeah, thank you. Okay, my name is Akshay Kumar Gupta, and I'm a Masters of Engineering student with majors in Computer Science and Engineering at the Penn State. And this is my final year, and will be graduating in August. Thank you.
Awesome. Garv?
Hello everyone, my name is Garv Jasuja. I'm also Master Engineering student at Penn State with Computer Science. I'll be graduating this August. I have around 5 years of experience, mainly in the backend side in C Sharp, .NET, and Azure.
Awesome. And Vijay?
Yeah. Hi everyone, and whoever may be listening to this in future. So my name is Vijay. Uh, I've worked for around 4 years in India in a solar energy company as a data analyst, and now I'm doing my master's in energy and mineral engineering. But my primary focus is on using data analytics and machine learning, artificial intelligence techniques to understand the real world systems, and that's where my contribution to our project, which we'll discuss further.
Awesome.
Glad to
Great.
meet
Yeah.
you.
Yeah. Thanks. It was nice. I met most of you actually in person last week at the Global Azure Conference boot camp, which was held in all over the world. Actually, I attended the one. I was co-hosting the one in New York City, and I happened to meet all these wonderful students, and they were telling me about the work that they've been doing in Azure, some of the prototypes and projects that they are creating for detecting heart attacks. And I thought it'd be an interesting discussion to have here to see how how in academia, how they're thinking about the cloud, how they're trying to leverage the cloud in academia for solving these difficult problems in the world. So yeah, so maybe one of you can just give us a little bit of a high-level overview on the project, and then we can kind of dive into some of the details as we go along.
Well, if we talk about the project in a very overview in a nutshell mode, so what we are building is what we like to call Alert Heart. It's a hardware device. It's a hardware device which is capable of recording the user's heart rate, breathing rate, and other such vitals wirelessly. So the user doesn't need to wear anything. This is not like a wearable device. Rather, it's like a smoke alarm which you put it on the top of your bed, and it detects heart rate and breathing rate. And then after collating that data using some kind of machine learning pattern recognition algorithms, we're able to detect if a patient is having a heart attack or a cardiac arrest. And then we send a notification to the caretakers using a mobile app, so or a SMS facilities, however they might choose to be. So that is the very overview, the nutshell version of what we're trying to build here.
And I believe you had mentioned that you're doing this project. You've been working on it for a while, and it's been part of some of the, I guess, competitions or contests that you have in the university, and even outside the university, right? I think you've kind of presented this project a few times.
Yes, that is correct. We were so initially we started this project in October, September. So me and Garv, we were in a class which was specializing in wireless technologies, and we read through some papers, research papers, and we started working on this project in September, October onwards. We first pitched it at a NITNI AI Challenge, which is one of the premier competitions happening at the Penn State University across all the campuses in the Commonwealth. And we are in the top 10 right now in that project, in that particular competition.
Awesome.
We are yeah we're thinking of the final will be in the September, so we are building this project in collaboration with various people. Apart from that, we have we have pitched this competition rather in the Happy Valley Venture Capital Pitch Competition. This was again part of Penn State Startup Week, and we were very fortunate to win a very generous prize of over $10,000, which we four of us actually quite enjoyed spending while building this project, I must clarify. And yeah, but apart from that, we also pitched this idea at the Microsoft Imagine Cup, where we were among the top 3 teams in healthcare across the whole Americas. Unfortunately, we couldn't move to the next level, but still we had a great exposure. We got really great feedback on this. And I think Vijay and me also participated in Yale. Vijay, do you want to talk about the Yale part where yeah.
Yeah, so we were there for the Yale School of Medicine annual hackathon. So it's conducted by the Center for Biomedical Innovation and Technology. And it was a really good experience because that was the first time we were getting real hard feedback from the actual domain experts. So the doctors, the practitioners, the residents, and the hackathon was filled with all of those people, and it was just a really good brainstorming session with them. We also got to know a few people who were giving validation to our product. So there was a lot of discussion during the hackathon time. It was majorly trying to know because all of us, we are engineers. All of us have bachelors of technology, and then here we are doing masters. So it's easier to say from an engineering perspective, but then we always need to have the domain, if not expertise, then at least the domain experts view to get to know because what we are trying to do is very personal and biological in nature. So what we are trying to do is very human centric. So it's very important to get to have these constant feedback sessions and validation from the stakeholders who are mostly involved in the system. So that was really a good experience. And then based on that feedback, we were able to even tweak it and include additional features like Akshay, Garv, and Neha can talk more on the LiDAR arm feature, and that was actually an innovation that came about after getting to know the different views from the medical community. And obviously, the data side of things, I I'm sorry. I try to handle the data analysis and assist Neha in the machine learning and artificial intelligence part. I'm not the best with the software side. That's where Garv and Akshay come in. But it's sort of a complementary team because they do that side of thing, and then Neha and I we get to do the other side, completing the whole package. And of course, we have the hardware and IoT stuff which we are tinkering with, and so that's how I see this whole experience as going forward as well, and we are excited.
This is really cool. It's always cool to see Penn State, I guess not grads yet, but grads to be doing well. My family actually is originally from just outside of Penn State. So I have a lot. I almost went there. I didn't end up going there, but I think what's fascinating when I hear y'all talk about this is, you talk about sort of the hardware piece and the software piece, and all that's got to come together. So it's really multidisciplinary at the end of the day. But I think the thing that fascinates me is thinking about what the cloud enabled you to do here, because 10, 15 years ago, I don't know that you could have done this. When you look at how the cloud sort of played into it, are there pieces that without the cloud you just wouldn't have been able to get anywhere near achieving the goal? What's an example of that?
So a little bit of background on myself. I didn't say that in the introduction. I'm like an Azure certified cloud architect. So I was the one setting up most of the cloud, and Garv is the one actually programming the cloud. So I'll just segue this after to Garv. So initially, what I would like to say, the major components of Azure, which I think will be defining for us, like one of the things is the notification part, obviously, to ensure that the phones are getting notified when the people are getting heart attack. That was one feature. But I think the core where we use Azure is to collect our data from an IoT-enabled device. We store that data and we run our machine learning algorithm. So it gives us a place to run our algorithms with the processing power we need, because sometimes we do need a lot of processing power. We do need it a place where the data is also available. So it cannot be on a distributed system. So data is quite fast available to us. Our machine learning algorithms are running. And all of them, I think, comes very beautifully on Azure when we have different components all working together. I think Garv can explain more on that.
Yeah, but I think sort of trying to, like, if you had to tackle that part as well as the hardware and the software that you built, like that would take this project and make it 10 times or 100 times harder, I would think.
Yeah, so like previously, like we didn't have a cloud. The main issue which we do face was because in this our project we are getting breathing rate in every second. So in every 60 seconds, in every minute, we have 60 readings. So there is actually no way possible to store all that data, and then after storing, process that data, that too in real time. So prior to cloud, I am not sure if that would be even possible to do that, even processing that. And in our project, real time is a crisp thing, because heart attack and cardiac arrest it occurs very suddenly, and the time matters a lot, because in the golden hour, if you can detect the thing and you can tell the caretaker or anyone, they can take the preventive action and person's life can be saved. But if it is not real time and we are not doing the real time analysis, I don't think it would be our project even would be a useful, because all the thing is actually the real time matters a lot in our project.
Yep.
Yeah. It's like at the end of we will be able to tell the friends that, hey, your friend had a heart attack and we are not sure how he is right now, but I'm pretty sure they had one at 2 p.m. yesterday. So I don't think that will would have solved
not as
any
helpful
of the
at that point. Not as helpful.
Yeah, exactly. And one more thing is that you see there we are like 4 people team, but had we not had a cloud, we might have like 15 or 20 people. Like some of them will be an IT expert managing our servers, making sure everything is set it up right, writing those long scripts of PowerShell and something like that. Thankfully, we didn't have to do any of it. So yeah, that was one thing I think. Yeah.
And also some of would be a security expert, because ours is actually a medical data. So
good point.
And there are a lot of regulations. Azure or any cloud gives that by default. They have all the compliances and certifications. If we have to do it on our own, I don't think we will be able to get that compliances anyhow.
Anyhow, yes.
Yeah, listen to this. Like something that sticks out to me, and maybe you could like educate our listeners a bit more on is a couple things that are kind of related. Like I heard you mention like you've talked to some physicians and doctors and things about this now, and it's kind of interesting to me. So sometimes projects start there, right? Like of saying, hey, a doctor had an idea or something like that, who's like very close to what this problem is, and then brings that to engineers versus engineers saying, hey, we think we have an idea here for something, and taking it that way. And also along with that, what was the inspiration for this? Was it I hope somebody didn't have a heart attack here, but like, what was their inspiration like behind this? Like, how did this start? Like, what was the idea that sparked this?
So one thing is that we all immigrant student right now. We have come from India here, so we all have parents at home, and this is something it's constantly. I won't say bother, but like we are always like, hey, how are they? And will they get the help if they need? Because an heart attack is something which is unfortunately quite common nowadays, and which is quite unfortunate, but it is. So when we were studying about using wireless radiations like Wi-Fi and 60 gigahertz radiations, and how users are able to extract heart rate from that, me and Gar, we had a sudden talk that we can use this, we can have this technology to detect heart attacks or things like that. And because we had some background in industry, both of us, we were like, yeah, we can build this. We have those expertise, and with some help from Penn State and our professors, we can probably build this up. And both of us had some friends who are doctors, practicing doctors. So the moment we had this brain, we were like, okay, let's talk to them. Initially, I'll be honest, they were not very happy with this, but because the machine learning component was not there, so they were like, you can't just use heart rate. So then we like, okay, then we talked to them, we discussed, and then it was all that's how Azure start factoring in, because we needed some place to run our algorithms, and our machines are simply not that well equipped to run such kind of algorithms and such kind of data. So I think Vijay, would you like to further elaborate on this one?
Yeah, I was just gonna say that I think a real validation of the product and a sort of like unintentional customer discovery came when we were assigned a mentor for the Microsoft Imagine Cup, and I don't remember his name. Maybe Akshay can tell, but we were pitching him our project, and then there were discussions back and forth, and then the mentor. He had to reschedule the meeting to a later time because one of their parents was unfortunately they were a little sick and they have some heart issues. And then in the next meeting, in the rescheduled meeting when we were pitching the product, then the mentor was like practically emotional. This is the kind of stuff which hits home and uh, which needs to be in use. So it was sort of very unintentional, but very serendipitous and surreal in the way that we had seen even in the mentor that this has become commonplace now, relatively commonplace. And the worst thing is that the trend is getting worse based on all the suggestions in terms of all healthcare indicators. And it's not just a particular country's problem or so on. It's a worldwide phenomenon. So I think it's really important to take action, and that's when during their wireless course, Akshay and Garv, they were brainstorming about this. That's when I joined, and I was like, yeah, because Azure is one of those premium service providers with a whole suite of data processing and machine learning pipelines, and it really makes things smoother from a data analyst perspective, and even as a machine learning algorithms engineer perspective, it makes things really easier and smooth and consistent because for not only for tinkering with the product or uh, uh, playing around with data, but in actual deployment as well. And it's consistent and reliable. So that's when we decided that okay, the pieces just perfectly fit into it. Azure will be the game changer, and then based on whatever knowledge we had. It was always a cyclical process of trying out, testing it, and then we we were very conscious as to venture out and try to seek as much feedback as we can. That's why we were part of various hackathons throughout the semester. We participated in as many competitions as we could, and then it was always trying to better the product, and then introduce more and more features. And like Akshay was saying, initially it was just about the heart rate, but then we realized that that again ties into our perspective of looking through things from an engineering lens. And then once you start gathering the real world information, and then once the experts view kicks in, then we start augmenting whatever we need to do, and then make it better. So that's a continual process, and uh, that's how I see the thing.
Yeah, I just want to mention the name of the mentor Vijay mentioned. It's a Microsoft MVP, Mr. Dwayne Matwick, who was the
Great.
mentor.
How did you, you talk about building the machine learning model in after getting some initial feedback, and what I guess, how do you test, how do you even get real data? Because like, you don't want to go induce a heart attack on somebody so that you can check your data source. At that point, is there baseline data somewhere that you started with, or like, how do you even know your model's any good?
Well, that is something which has been a constant feedback from all the people we have project presented to. So what we have done is, what we have relied on is, we have some case studies which have been published by the doctors from the 1990s onward on to 2016, where they were able to collect data from patients who had heart attack.
Oh, okay. So you had the
yes,
data set to start with. Okay.
Exactly. Yes. And for now, what we are trying to do is, once we are, like right now, our product is in a prototype phase. We do have a product, and we are also diversifying our product, because like there's another student at Penn State. He has a ring which works similar to a watch, so it has like a heart rate sensor inbuilt in it. So what we are trying to do is diversify our product, and finally our aim is that there's a Penn State Hershey campus, which is like the medical school of Penn State. What we are trying to do is getting our product in the medical school or in an elderly care home center, because elderly and the people of higher age are higher risk of having heart attack, and hence the product is intended to be used for them. So what we're trying to do is put our device in some real locations, gather the data, and see if our models are able to do anything. I think Neha has worked on some models, so she wants to add to this.
Yes, basically we're right now working on those models to create. So basically, we want to personalize this model for every patient. So we try to get the baseline data for every patient, and then make a model which can learn from that, and which can later help to predict any anomalies based on the later feedback, or later feedback that we get from our device. So we're working
It's
on those models, and we're also leveraging the Azure machine learning studio for that. So we're trying to use the designer also, which makes it pretty easy and helps us build our models pretty rapidly. So yeah, it helps us
initi-
basically go the end-to-end machine learning life cycle. So we're trying to
yeah.
leverage.
Initially what we're doing was just had a set of data, so we put it through different models, because with ML Studio it's very much possible. So you have like
Yep.
similar pipeline feeding to different models, and then we get outputs, and okay, which model is performing what. So this was one of the things that we were using. But again, our major objective was to personalize this for each patient, because everyone has a different heart rate, especially when they're asleep. And our device, the biggest selling point for our device was that it works because you don't have to wear anything. And usually when people sleep, they don't like wearing like watches or rings or whatever. So it was like, that's what we are targeting, like people who are living alone, sleeping alone, and our device will help monitor that without any invasive or minimal invasive. Yes.
So I wonder if you could walk me through this data pipeline. Right now, we talked about how these devices are going to capture some of the signals that you're getting. What's the next step in this, and how does it like flow through the data processing pipeline? I was wondering if you could just give us a high level overview on that.
Sure. Garv?
Yeah, yes. So what we are basically doing is our device is connected to the cloud using IoT Hub, Azure IoT Hub. So it is collecting the data, and we are doing some pre-processing in our device ourselves, so that to filter out some anomalies or some, what I would say, a sound or something, that type of data we are filtering out, and the rest of the data we are sending using IoT Hub to the cloud, and we are storing it in Cosmos DB. And on the same side, we are using Azure Stream Analytics to do the real-time analysis using our model. So through that, we are analyzing. We have set up a window of time, and in that time, Azure Stream Analytics is doing the analysis. And if we found some anomaly or something, we send the notification using Azure Notification Hub to the user and the caretakers and the other persons. And on the other side, the data we are storing in Cosmos DB, we are using that to train our models using transfer learning time to time, so that our model gets accuracy gets better, it predicts the better prediction, and that is also on the user basis. That is not on the overall model. It's basically the user specific model, and it keeps on getting better and better every day with the data we are getting.
Another thing which we are doing is we have a LiDAR sensor. So it is similar to the sensor which is used in Teslas and all the cars to map everything in 3D. So we had a custom 3D printed arm designed for it. So it rotates LiDAR in 2 dimensions. So what we are getting is a 3D point cloud of the whole room. So it is very similar to what like devices like HoloLens do. They try to create the whole room in 3D. So after that, that data also gets collected and on the server again using the IoT hub only. And the data, Vijay has a data analysis, a pattern recognition algorithm running in the cloud. So what it does is takes those data and it tries to find a human in that particular set of point clouds. And with that, because our assumption is that when a person is having such kind of cardiac arrest or heart attack, they tend to clutch their chest or they tend to clutch their stomach or something like that. So we are looking for those distress signals. So basically what happens is, say, if a heartbeat anomaly is there, it might be because they are having a nightmare or a very good dream or some other reason. But having this kind of helps us to eliminate false positives. And once we eliminate that, as Garv mentioned, our model gets trained to understand, okay, for this person, maybe a heart rate of 100 is not that bad as compared to, say, another person for who a resting heart rate of 60 is good enough. So that's how we are trying to retrain and learning from the models.
Also with LiDAR, the main advantage is it is not intruding your privacy because there is no camera in that or anything. LiDAR just makes the point cloud. So there is no way you will have some hesitation to install that in your room because there is nothing which we are storing or which we are getting from your private privacy.
Yes.
Very cool. Yeah, the question I had backing up a second there, I think Akshay had mentioned like other devices like rings and things like this. So maybe could you expand on that? Is the idea like for instance, you could have the technology and the device you guys have been working on and then complement it with these other ones, meaning like you can get an even stronger signal or more confidence in it because I have now 2 or 3 devices that are actually feeding me this thing.
Actually, yes. What we are doing right now is we have another Penn State student with us. He's a PhD student. He has joined team, I think, yesterday officially. So what he has built is he has built a ring which has a PPG heart rate sensor in it, and he's also trying to integrate a EKG sensor in the ring itself, similar to what we have in Apple Watch or Samsung watches. So the idea, but what this suffered from is the problem of battery life. Because the ring is a very small form factor. So what the idea is that the ring does not need to connect to any phone now. It will connect to our device and use the same pipelines which we have built. So this way the smartphone dependency gets over with. And second is, say our device detects that, okay, this person is probably having a arrhythmia, a heart attack or something like that. We send a message to the ring through the cloud that, hey, take an EKG right now and tell us how it's going. I mean, it's like one device is complementing another one, and both of them together are. So basically, the ring had a shortcoming that it had less battery and it required a phone to connect. So that shortcoming is addressed by our device because now the phone, it's like a smoke alarm, right? It goes on the ceiling of the room. So the moment ring sees such device, it can put all the data to our machine learning pipelines, and so we can do. So this is how we are trying to integrate. So in a way, what I'm trying to say is that probably what our device is, it may become a kind of platform for other devices to come contribute their data, and also become a platform for other devices to get insights. So like watch gets insight, hey, you may want to check on your patient, maybe they are fallen or something like that.
I really like how you've taken into account all of the privacy concerns. That was really nice to see. I'm just wondering how, in the pipeline itself, how do you ensure that the patient data is anonymized, right? Like obviously, if you're training data and things like that, you don't want to. I don't know if you use one person's data to train another. Whether there's any privacy concerns in that, is that something that you have to address?
Yes, we had to address this because when we basically is something like when we are storing anything, the data has to be anonymized. So when we train some model, it's trained on personal data. So we train it and then we kind of remove that data because we have extracted learning from it. And for the long training purposes, we store it anonymously. Garv, again, over to you for this part.
Yes. So we are basically taking very minimal information from the users, and there is the how we are differentiating user bases based on the device ID which we get. So there is not much information stored in the database, first of all. And second of all the data which we are storing also, we are deleting that after 14 days. So all the training of the model or anything we have to do, we do that in 14 days. And after 14 days, all the data of that user, including the heart rate, breathing rate, the gestures, everything is deleted from the database. So there is the chances of getting it leaked is very minimal. And second thing is, even if it is getting leaked, there is no user data in that. It is just a random ID you will be getting. So there is no way you can track for which user which data is there.
Very nice. Thank you.
So my specialization these days is about sort of the reliability of the architecture and the application. And when I talk to people like yourself, a lot of times it's, hey, we're building this cool functionality and it's going to be this neat technology, and then it's all running on a single VM, in a single region, and if there's some sort of failure, like it doesn't take much of a failure to take that workload down. Are y'all at the point now where you're sort of considering what this would look like from a reliability perspective as well, or is that future work that you're thinking about now?
Well, if I'm absolutely frank, I will say it's something like future work, but still, because again, we are using Azure, we are not using VM at all. Actually, we have distributed services, we are using multiple services, and when we are using Cosmos DB, as Garv mentioned, Cosmos DB, we are using redundancy to ensure that at least our data is redundantly stored. And models are also stored in a storage account, which also provides us with that kind of redundancy that we require. But apart from that, yes, but as we move further in the development cycle for this product, things like security, privacy, and of course reliability, these are the three major things which we are focusing as our product comes close to reality, or rather close to, we can say, real life data use, real life situations, real life usage, commercializations, and things like that.
But I think you do raise a good point. Is there some level of reliability and resiliency that's built in just by using these PaaS services, right? It's probably not the full layer that you need, but you get some to start with. And again, it would be much harder if you had to build all of that to start with.
Yes. And also we are, instead of using the SaaS, we are also using serverless things. So we are using Logic Apps and Azure functions. So by default, there is not much we have to do on our side. Everything is managed by Azure, the reliability, the SLAs, and everything. So that's why we are trying to use as much possible the serverless things and the services which Azure provides, rather than using the app services or VMs or something like that.
Because having a vendor like Azure giving us those SLAs, it's really convenient for us. As you mentioned, had we been doing everything on our own, setting up our own servers, this project would have been like, we would have completed our PhDs by then, I think, before we would have seen this project. So yes.
Good, but you're thinking about it though, which is great, right? Because again, a lot of people don't even think about it, and then you're trying to bolt it in later, and you've made design decisions that it's really tough to go back and redo at that point.
Yes, that is correct.
This is really great having this discussion with you guys. Do you have a name for this product? Like some sort of have you come up with a cool name for it yet, or is that something still work in progress?
Well, as of now, we like to call it Alert Heart, and you can actually go to www.alertheart.com, and we do have that domain. And I believe, Garv, we do have a website also, I guess. We do have some pages.
Yes. Yeah, we have that.
And it's on Azure, right? The site's on Azure as well, right?
Yes, of course.
Of course, it is on Azure. It's like once you start using Azure, I don't think you see the world the same anymore. You don't look at other services then, because it is such a complete package.
And also we come from the Microsoft domain, the .NET C#, so we use Visual Studio. So deployment through Visual Studio to Azure is just a single click thing.
Just a single click.
And doing that on some other cloud is really a time-consuming thing.
Yeah, we don't have to open PowerShell. We don't have to do anything. Just tuck, and that's it. Server deployed.
Oh yeah, sorry, I didn't raise my hand, but I just had one other question about that specifically. Open source. So how much of this is this open source project? Like some of the, especially like the models and stuff that you're building, is this something yeah, obviously maybe you guys are going to make a business around this or something like that potentially, but also like, is there pieces of this is being fed back into the community like through like OSS or whatnot?
As of now, not really. But we do aim to do that because at the end, when we see ourselves in future, we don't see ourselves as a product company. Rather, we see ourselves as a research company, which is focused on building those data sets, building those models to help people get the treatment they deserve at the time they require. So that is how we see the future of us if we build it as a product and as a company. So we see ourselves completely focused on researching and developing such techniques. So right now, it's none of this is open source, unfortunately. But as we move further, as we move our product, build our product better, we obviously look the models to be open source and getting back from the community and giving to the community, both of them.
Yeah, no, this is great. I mean, it's great to see the investment from academia. It's great to see the investment from y'all. I mean, this has to be a ton of time and effort, right? As well. And so, great to see the innovation and investment in people's health as well. So, wish you all the best of luck and, keep us posted. I'd love to see one of these in my, in my room at some point.
Thank you.
Yeah.
Thank you.